Oh, hello there. Hey guys, what's going on? Memes here. I don't know about you, but all I know is big science is totally hiding the truth. Now, I might not know what big science or the truth is, but if I watch it on a podcast I like, I know it must be true. Why? It confirms my beliefs. Um, yes, yeah, it's gonna be one of those episodes. Yes. Oh dear God. Help us all. All right, all right. Let's see. Where are we? Where are we? All right. Now, oh God, people seem to actually pay attention to this. Oh, you used the word big science, big science. Oh, it's something that's big. And if we're saying it's the big insert thing here, we all know it must be bad. Because we don't go around blaming the little guys. No, 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 no. We need to blame the big arbitrary thing. Now, maybe that is the case. We're gonna take the Everett interpretation literally. If we believe there are many worlds, and there's gonna be an infinite number of branches of our reality in which all the potential situations occur, well, in that case, big science is totally hiding something. Now, is it within this universe? I cannot say. I cannot say. Uh, where does this come from? Let's see. Okay. Well, we've got oh, let's just go to the thumbnail. We got it right here. All right. So of course, the best comments come at like 2 o'clock in the morning on Twitter. As we can see. And now my evidence is, well, obviously this verified account on Twitter said it, so it must be true. It's got a blue check mark and everything, so just pay for play. Of course, as we can see, big science is totally hiding the truth. Now, I don't know who big science or what the truth is, but if it's on a podcast I like, it must be true. So we're just reiterating what we said on Twitter, and we all know nobody would go on the Twitter, start a situation, and then just make a YouTube video profiting off of it. I mean, some would say, I am reporting the news. Well, if there's one thing I've learned from the scientific method is there ain't no such thing as an enclosed system when you're part of the entire system. We just try to account for the infinite number of potential variables and do the best we can, right? Right? It's not like we would let our personal biases in on these things. And so this is where I have a particular plan for this whole thing. Most of this was just chat interaction, so feel free to interact, share the different ideas and everything. And we may have an announcement coming towards the end. I'm thinking about doing something along the lines of what Anastasia and Shiloh do for was it Paradigm Drift? That's a show that I've statistically been picked more times than probably should have. I think I've appeared on it like 5 times or something. But basically, they'll hear yeah, people give their 1 minute pitches for theories and stuff like that, and then they'll kind of go through and then just kind of do a quick like 10-minute interview, just kind of like probing, like, okay, what are you actually doing here and everything. And I kind of found that very useful, just because um the feedback was good. The feedback was good in that I can ramble about all different things, but it's like, can I get to a point? Doing it in a minute can be pretty hard, especially if you're one of those folks that's like, okay, I have a theory. Okay, what to do? It solves everything. Okay, how does it work? Well, and then you wave your, well, we need to go through all of it. Okay, that's fine. Can you give us the gist? Because it was Professor Feynman, and when he was asked, it's like all knowledge is lost for modern humanity and stuff. What's the one statement in a minimal form that can communicate the most benefit to humanity? Professor Feynman's response was something along the lines of matter is made up of atoms. Okay, basically, there are smaller constituent components to the stuff and things that we see here. All right. Welcome, Rick. Oh, big science can't handle the truth. So interesting story. And again, I'm not saying this is a big science thing, but this might go more along the lines of, but this is what we always do. Um, our friend Kurt J. Mungle from the formerly Theories of Everything podcast posted an interesting thing earlier today. Apparently, he came across a researcher who had, oh God, was she in biology or something like that? I actually haven't even gone through the whole thing yet. But apparently, I think she might now work for CERN, and she was highlighting a potential, let's say, error with our methodology, or let's say our process of going about and modeling what is known as dark matter. I think that may have been interesting, and I may or may not have commented with a particular clip from the frontiers of science over the past year or two, but that may or may not have been done. If you're open to it, I know it involves you, Rick, but I'm happy to share it because I may or may not have been a direction that I wanted to go in. It's up to you, my friend. Uh, okay. In the meantime, I'll continue to bloviate. So, big science. What is big science? All right. Well, let's think about this. It is well established, organized, bureaucratic investigation into what is going on. Now, very often, what's that? You get paid. You get paid to do science. Isn't that what it is? Isn't that how you become a professional in something? If you're a professional scientist, you are paid to do science. If you are a professional YouTuber, you get paid to do YouTube. Okay, aka you're a professional influencer, you'll get paid to influence. Saying those words right there, does that just mean we're all a bunch of lobbyists? Because that's what it kind of sounds like. A person, an influencer, a professional influencer, is somebody that is paid to influence. Oh God, maybe I spent too much time in the political sphere. My mind just automatically goes to that's literally the job description of a lobbyist. What is a lobbyist within? And we won't go into the generalized thing in the United States as a constitutional republic. Basically, people can have individuals that literally would be in the lobbies of Washington, D.C., and kind of wave down, be like, oh, the congressperson, oh, we should go to dinner. Let me lavish you and tell you why my particular industry, this is something that we're very important to us. So basically, you would get the ear of said Congress folks, and literally from catching them in the lobby, and you are paid to do that as a representative from the professional organization, whatever industry it might be, energy, agriculture, this, that, or the other thing, technology. But I just find it interesting that, like, okay, if you're getting paid to do that, is this one of the big things with a lot of cuts to science and everything? Because it's like, are you a scientist if you don't get paid to do science? I would argue yes, yes. Now, are you a professional scientist? If professional means you get paid to do it, is that the best thing? As far as I know, because the interesting thing is you go back, and this is something that I think Shiloh has brought up before, is that a lot of times if you go back, a lot of the greatest quote unquote scientists of all time, when you're going back in the past, a lot of them, like, that wasn't necessarily their job. Like, there wasn't necessarily a professional scientist. It's like a lot of them, like, were like attorneys, artisans, engineers, and stuff that just found these things fascinating and would investigate. And yes, a lot of these folks were people that had means, because Well, if you don't need to worry about where your next meal is coming from, and you happen to have some resources where it's like, okay, I can do some cool experiments. And guess what? That requires money, that requires time, that requires the ability to investigate things. And one of the core things is it requires time to think. And one of those things is having uninterrupted ability to think from some of the smartest folks that I've met seems to be an important thing. Now, if you're a professional scientist under the current paradigm, and generally what is it? Okay. You have some stuff, and I'm going to use some hyperbole here. Again, I'm not an attorney. Feel free to at me, bro. But the concept is, okay, we're scientists. We're part of a group. We're some part of some professional collaboration. Okay, we're going to submit to get grant money. Okay, what do you often do? It seems, at least from folks that I've heard, like Professor Carroll, and again, just what I take away from folks on the internet that would like to see the process actually revised, because I'm sitting here, I'm like, well, if a lot of folks, if we're all like, this is a broken process, and we just keep on going the process, like, wait, what are we doing? Because basically, you submit a grant proposal, and a lot of times it almost seems like you're saying what you expect to find. In that case, what are you doing? Like, you already have results, you say the results, you submit it, and you're like, okay, we're going to find this thing. Are we researching, or are we just kind of like going upon like what we've done, and then like, okay, we're going to incrementally do this, we're going to incrementally do this? It's like, that's fine. And for a lot of things like material sciences, condensed matter and stuff, we seem to be making a lot of progress. Why? Because we can do experiments, we can see what happens. There's interesting stuff going on. They're talking about putting a potential like virus into a superposition to test it, because we apparently put like 7,000 atoms of sodium into a type of superposition, and it seemed to work. It seemed to show these weird effects, whatever might or might not be going on there. So, all right, I can groove with that. What is going on? Now, people have a lot of different explanations, and it's a very fascinating thing. But let me go through here. Let me find, where are we? Oh, all right. Oh no. Oh, negative. Oh, I actually got asked the question. Hold on. It's let's see. Well, since we're talking about the big science and everything, let's go to something that disagrees with big science, because that's the theme of our show. I mean, it's not like yesterday. The whole broadcast was that Professor Wynn would not lead us astray. Oh God, what type of box do you put this dude in? Well, apparently a little 1-inch box, because I'm in a box on the corner here, but categorization of a particular person. They're saying this, they're saying that. All of this with a wiffle ball bat. I don't know. And again, the Memes of Destruction channel does not promote violence unless we were to legalize dueling. I digress. Okay, so it's from Mr. Kurt John Mungle from about 3 hours ago. Let's digging this a little bit. All right. So apparently, according to Kurt, the physicist just told me that 85% of the universe's missing mass may be partly a modeling artifact. Jenny Wagner is someone I didn't expect to meet, but I'm glad I did. She proves theorems about what the data can't tell you. Then she shows where the standard model of cosmology silently fills the gaps with assumptions. She calls it CSI cosmology. Start with the evidence, not from the theory you like. It's super interesting. What's even more astounding is the cross-disciplinary impact of this sort of approach. It may have a drastic impact in particle physics and even in cancer research. This goes beyond AI/traditional machine learning. She has a PhD in machine learning, actually. Oh, how very convenient. In fact, a quantum chemistry thesis she read cracked a 30-year-old degeneracy problem in gravitational lensing that cosmologists couldn't solve staying inside cosmology. This is the part I am unaware of. Okay. Quantum chemistry thesis. Oh, degeneracy problem in gravitation. Oh, wait a second. Are we saying that things that might be relevant within a particular discipline may actually be very effective and highly useful within other disciplines? I totally agree. Quick shameless plug out to SEMF. That's the nonprofit collaboration that my friend Carlos Zapata from the Wolfram Institute has started. Basically, the whole purpose is to bring together folks from across all different disciplines, some folks that happen to be professional scientists, and then some folks that maybe are more like myself, more like enthusiasts, folks looking for interesting things, trying to figure out what's going on, and in our wildest dreams, maybe being able to help contribute to other folks and their work. And hey, if we can move humanity forward, isn't that the whole goal? I mean, isn't the goal to level up? Yes, I actually have the shirt on this time. Okay. Oh, yeah. There's apparently a fiber outage in California right now. I saw the Internet Archive post something about that on Twitter. Apparently, if some of y'all happen to be having some internet issues currently, especially if you're on the greater West Coast, there's a good chance because apparently there was a fiber outage somewhere in California, and California is kind of home to Silicon Valley. If there's a fiber outage at the heart of the quote unquote technological world, and again, this is a very American bias here, that may lead to some interesting things. But okay, Rick gave us the okay to play the little clip, but let's finish our reading of Mr. Jai Mungal's post here. Okay, so this is interesting. So the claim is that a quantum chemistry thesis she read cracked a 30-year-old degeneracy problem in gravitational lensing that cosmologists couldn't solve staying inside cosmology. That sounds fascinating. All right, so the claim is, what is it? Where else in physics are we confusing model artifacts for discoveries? Okay, we go into Kurt's. Okay, there's a little 2-minute preview there. Let's see. Am I gonna have to start a Substack and start going over some of these things? Oh, I'm sorry. I just realized I didn't swap to this tab. Okay. So, all right. You know what? This is a 2-minute clip. Don't copy strike me, Kurt, at all. All right. Let's see what we got. This is a little preview, and if you want the full interview and article, you can always subscribe to Kurt's Substack. It'll probably be out for the rest of us on YouTube in the next day or so. Let's see.
This is my gravitational lensing problem. He just said, oh, finally, you got it 30 years after we found out. And it was quite astonishing how disruptive you think something could be.
Disruption, you say?
Dark matter. 85% of the universe's matter is supposedly missing. But what's the technical truth behind the popular science headlines? Dr. Jenny Wagner, a scientist at the Institute of Astronomy and Astrophysics and the Helsinki Institute of Physics, and winner of the Prize for Courageous Science, disagrees about how we got that number. This is because she proved mathematically that most of what we call evidence for dark matter is driven by the models we insert and not the data we collect. On this channel, I, Kurt J. Mungle, interview researchers regarding their theories of reality with rigor and technical depth. Today's episode is no different. Wagner found that when you strip out the model's assumptions, the only information that the data gives you is local. This means every grand dark matter map you've ever seen is extrapolation. Now, it's not wild speculation. That's not what she's saying at all. Specifically, she's saying a profusion of models can all fit the same data equally well. This is called lensing data. By the end of this podcast, Wagner makes the case that this is what Einstein predicted over a century ago. The homogeneous, isotropic, spherical cow model of the universe eventually needs to be replaced by the next level of detail. Today, she shows us how we may finally be there.
Oh my God. Wait. How dare you? How dare you say that the spherical cow is not our actual reality? Oh, you mean like they explain like this is not actual reality, but we're attempting to model reality, and well, it's not like if you're using a sphere to model things, you're gonna get out a sphere. Okay, let's finish this last minute.
What do we actually know about dark matter?
Dark matter. Dark matter is something that I wouldn't say it's something that we know about. It's rather it's a term that came up because we missed matter when we looked at our observations. And so dark matter was the replacement or was the substitute for this missing mass in our explanations of certain observations. For instance, in observations of the cosmic microwave background in the very early universe, but also in the late universe, where we have cosmic structures that seem to be hold together in a gravitationally bound object. But then if this object is actually gravitationally bound, then we miss a lot of matter because the luminous matter that we see, the baryonic matter, this is too little matter in order to keep this structure together. So if we do.
All right, and now we've hit the paywall. So I'm pretty sure there's an RSS feed. Full disclosure, I am a patron of Kurt's. So I know there is an RSS feed that I think I can just get it from. I never actually set it up, and we'll leave it as that, just because. I mean, he's putting it together. He's putting in the work. So, okay. So we have that. Okay, they go over there and oh, what's this? A comment? What was this? It was this random internet weirdo. A guy named the Memes of Destruction. God, you know he's a crackpot. All right. Modeling a disk galaxy as a sphere, leading to an apparent halo of dark matter? But that's what we always do. It's not like anyone has pointed that out before. This is a link. You need to be wary about links on the internet. All right, I'm going to click it. All right. I have clicked the link. Let me upgrade this to actual quality because I made it out of a random playlist going in the background because I'm so ADD. But all right, all right, so this brings us to FPLS. So that's like what is it? The Frontiers of Science or something. There's the mystery of the dark matter in the universe. University of Washington physics. All right. Oh, and this was streamed about a year ago. Oh, but we've got a timestamp. Let's see what might or might not be going on here.
Hello, my name is Rick DeWitt. Could you please go back to the slide that had the large halo around the galaxy, the dark matter halo?
The artist rendition one?
Yes. Way back there.
That's way back. It'll take a while.
Back. So when we do computer simulations of galaxies and the rotations, we use Newton's law of gravity. Newton's law of gravity is based on spheres So this halo is a sphere. So if indeed our Newton's law of gravity is not applicable in this situation, the error would come from the modeling error of improperly using Newton's law of gravity, and the error would look spherical, just like that.
Well,
Wait. But that sounds like what Kurt's guest just said. And I just saw that today. Yeah, a year ago? October 22nd, 2024. But this is what we always do. All right, let's continue our blasphemy.
you're right. On macroscopic scales like this, Newton's laws are fine. And people, in fact, people thought, instead of dark matter, what if we modify Newton's laws? That was called modified Newtonian dynamics. And the idea behind that was it was initially just supposed to explain those rotation curves, those flat rotation curves. And the idea was that when you get out, that Newton's laws are fine here, but as you get out to very low acceleration out there, that you change the laws a little bit. And that actually does explain rotation curves just fine. But I showed you about another 5 pieces of evidence for dark matter, and it does not explain those as easily. So that initial, that was just a simple equation mocking up what a rotation curve what Newton's laws should change with. Later versions of it became more sophisticated mathematically. And in the end, in order for those to work, you have to have a new fields, and you still have to have dark matter. There's no avoiding it in order to explain like the cosmic microwave background. You absolutely have you can't avoid dark matter with these modified versions.
The point is that if you were going to make up a fudge factor, that the fudge factor would look like dark matter and the dark matter would look spherical, because your underlying theory is spherical, and that's the thing you're fudging. So it's possible that dark matter doesn't exist at all, and the model of gravity is incorrect.
Well, the only variant of that there is a variant of that did make sense mathematically, and as I was saying, it doesn't really work with the observations. You have to have new tensor, new scalar, and new vector, new tensor, new scalar, and dark matter. And that's not, I don't think a lot of people are working on this anymore without a dark matter component.
All right, see? Nobody is working on it. Therefore, it must be wrong. That's Rick is commenting, you're right, but we can use Newton's laws just fine. I mean, come on, listen. It's obviously a spherical cow. Now, my little random conjecture about the spherical cow, I mean, that's obviously got to be wrong, because, I mean, we're using kind of a sphere there, even though the Higgs boson should have a 2 pi factor to get its mass there, but then we say it's a spin zero. I digress. That's beyond the point. Here's the thing. Some people have tried. It hasn't worked. And obviously, you're going to dark matter. Why? Because that's what everyone else is doing. That's where the money goes and everything. So obviously, it is dark matter. Just because we're modeling a disk galaxy as a sphere, and then we get a quote unquote spherical halo, because how else can we account for those stars or anything? It's not like we're missing a gorilla or anything. Like we heard, like the smartest folks would say, they are using the dark matter because, well, we're building dark matter detectors. So what's the matter? I mean, it's obviously missing matter. Although Professor Tyson says that it might be more appropriately termed dark gravity, whatever that may or may not be. But we see these galaxies rotating, and apparently they seem to be rotating too fast and they should be flying apart. And then there's got to be dark matter, although, I mean, according to Anton Petrov here on YouTube, another interesting channel, in my opinion, that apparently they've found some galaxies where stars are rotating just right and there doesn't happen to be any dark matter. Dark matter is totally a thing. We are not on a wild goose chase. I mean, listen, we've invested so much money in this. Now, as a business major, I can say that there's this concept called a sunk cost. Basically, you're investing in something. You believe this is the next big thing, kind of like an iOmega zip drive. For those of us that were alive paying attention to storage technology in like the late 90s, and I think it was late 90s, early 2000s, probably late 90s. Before we had those 3x5 floppies. Okay, and then we had the bigger discs, but you had your 3.5-inch floppy. I remember one of my cousins used like 11 or 12 of those to install the original Grand Theft Auto on like a 196 megahertz Pentium computer. I'm like, all right, that was fantastic. But we also had CD technology. Now a CD burners were coming around, but those would take a while. So, but a CD could hold around the time around 600, 650 megabytes of technology, maybe a little after that point. But the iOmega zip drive, rather than your like 1.4 megabytes or so of disk space, you go up to 180. It's supposed to work really fast. And it's such a fantastic. And people were investing it, and then the price of CD burners and technology came down. You could hold multiple times the storage, and iOmega zip drive went from very premium thing to basically it crashed. You might call that a sunk cost. That whole company may have actually gone under now that I think about it. But basically, if you're working with a sunk cost, you're investing in something, you think this is going to be a good thing, it doesn't quite work out. Now, some folks, if you realize it's a sunk cost, you have to just say, listen, that money is gone. That investment is gone. We need to move on to something else. Now, there's also the thing that you can do is like, no, we're just going to change this component. We're just going to change this. We're going to modify. We're going to do this or that. Now, again, I'm not saying that dark matter is a sunk cost. People have built careers on this and everything. So, but like Dr. Freeze had pointed out, that people have worked on this and they've done modified Newtonian dynamics. And apparently, in order to account for all the different phenomenon, we need to modify these things. And then basically we're adding on epicycles. So now, okay, you need a different field network. You need different tensors, this, that, or the other thing. I mean, the alternative explanation is we've just missed something. There was some gorilla that walked across our screen at some point. It beat its chest. And then it just continued walking off. And we were just all staring at dark matter. Now, Stephen Wolfram may support that hypothesis because, I mean, he has conjectured that his general thoughts on dark matter are it's likely the caloric fluid of our time. What does that mean? Basically, Clausius. I think Clausius was the original gentleman. When looking at steam engines and basically like boring cannons and stuff, it's like, all right, we got some friction here and stuff. Well, we generate heat. Well, and heat seems to flow. Well, what else flows? Water flows. So if heat seems to flow, it's obviously it's a fluid. So it's a caloric fluid. That's where we get the term calorie from, because we measure them with calorimeters, i.e. The things that are in the Large Hadron Collider, or at least in some of those components. Oh, there's also an amazing series that the ICTS has. The ICTS is basically India's version of the Institute for Advanced Study, where like all like the smartest folks are at. There's an experimentalist from I think CERN and like the other colliders. He's been giving a presentation there, like it was on like part number 3 there, but he's going on like, where is the energy lost in these colliders? And it's fascinating. It's fascinating just because it's hearing the experimentalist that's actually aware of like the theoretical thought process and just going through this, and just some of the questions are really good. It's I might actually do a watch along with that sometime. But okay, all right, wow, okay, a whole bunch more people there. Oh, Mike is conjecturing to avoid internet issues, avoid California today. Well, that seems to be fairly interesting. Mike is conjecturing. It would be funny if interstellar dark matter was just dust. We don't believe it's dust, even though, because the thing is, dust would still even have a signature, I believe. I know Kali is, well, there would have to be a lot of dust to do that. I mean, I've heard Bill conjecture that the further you get away from a gravitational field, the higher gravity would get up. I'm still trying to grok how that might work, but it's an idea. Rick is saying he resembles a lot of those remarks. All right. Let's see. Okay, Bill, it might not just be you, because apparently there was I think an outage in California along one of the fiber networks. So I mean, California's kind of the backbone, because a lot of the internet, I'm not gonna say it's connected via a series of tubes. Conduit, having little pieces of silica that kind of happen to have a particular resonance. It was like a 1500 nanometers or something, and silica glass seems to have a resonant frequency or something like that. And then you can have your repeaters. I read something about it like last night. It's, and again, on the Twitter, so take it what it's worth. Yeah. Yes. Assume Earth was shaped like a cow. Assume a cowlical Earth. Let's see what you did there. Okay, so that's what Bill was talking about. That if gravity was from entanglement resolution, then dark matter is ordinary matter emitting at a higher energy. Again, that's conjecture. I ain't no god or prophet, so I don't know. Hey, welcome, Keisha. Good to see you. Good to see you. We're just rampantly speculating how big science is totally holding the truth, hiding the truth. Oh, yes, they're holding the truth. Holding the truth in the palm of your hand, just for a single crackpot to come along and figure out our secrets. Oh, hold on. There's a meme I gotta share. Okay, I was getting ready to use this for the thumbnail. I totally stole this one from Kyle Hill. So here we go. Bilbo GPT. Wait a second. Bilbo's got an iPhone. He's talking to the chat. It's like, after all, why not? Why shouldn't I keep it? You're absolutely right. You found it. It's been with you a long while. And it's only natural to feel fond of something that served you so well, especially when someone like Gandalf suddenly seems to want it for himself. I'm sorry, I just found that hilarious. I'm just saying it's again, whatever tool you want to use, you can feel free to use it. It's also the whole trust and verify. And again, maybe the big thing is just think. Because I mean, if you think through a process, you're like, if you end up in the point where it's like an old Disney Goofy bit where it's like Goofy is like flying along in something, it's like he's missing the entire undercarriage of the plane. It's like, something wrong here. There's something wrong there. Maybe we should reevaluate. Maybe our model for this random thing we think we're flying along with a bicycle, we're missing our entire undercarriage and everything else that's powering it. Again, I'm not saying that we've just missed the gorilla. Again. Many worlds. Everett. In some part of the multiverse, that's what your particular flavor is. There exists a world where we have missed a gorilla. Now, it may legitimately be an actual gorilla. Who knows? Maybe there's a cosmic gorilla that's going, oh, dark matter, I'm just wiggling my fingers, gravitational flux. Oh, God. Okay, I'm going to say we probably would have seen the gorilla hand by then, but that's that's a wee bit more speculative. Yes, welcome, everybody. Oh, Rick is claiming dark matter is a sunk cost. Okay. Speaking of dark matter, let's do this. Dark, what am I doing? Oh God. Matter. I need a okay, we got a quick 1 minute clip from I think this is from Cambridge University, maybe. Oh, tab, boom. It's from a few months ago. So
there are lots of mysterious things in physics, like dark matter, for example, is a mysterious thing. I have a suspicion about dark matter. I don't know if this is true yet. Hopefully we'll know in the next few years. But if you go back to the history of physics, in the 1800s, people were really wondering, what is heat? Well, they didn't know, but they knew it flowed from one thing to another. And so they thought, well, what flows from one thing to another? It must be a fluid. So they had the idea of caloric fluid. And turns out heat isn't a fluid. Heat is the microscopic motion of molecules and so on. Well, my guess is that dark matter isn't matter, and that in fact it is the pretty direct analog of heat, but in the structure of space-time. So once you have a discrete model of space-time, there is the possibility that you have all sorts of microscopic dynamics of the internal structure of space-time. And my guess, may or may not be right, is that dark matter is actually a large-scale manifestation of that, just as heat is a large-scale manifestation of the motion of molecules.
Well, Stephen Wolfram says it a lot better than me paraphrasing him right there. I mean, that's where I got it from. Again, that's just an appeal to authority from Stephen Wolfram. And again, it still seems to be a mysterious thing. I mean, gravity, as far as we've measured a lot of things, and I remember the standard model has been evaluated up to 14 significant digits. The anomalous magnetic moment of the electron. Okay. Not all of it has been evaluated that far. That's basically like our highest precision thing. But a lot of the standard model has been evaluated to like 10 significant digits. Why? Because speed of light, we got the 9 significant digits. H bar, we got, okay, again, it is 9. I thought it was 10, but apparently I missed a digit or so when I went to go check last week. The magnetic constant and everything, it's, I think we have that to 12. The last 2 digits have error in there. Electric constants, I think like 10, 11, 12 as well. Mass of the proton, electron, neutron, we got those to like 10 or so significant digits. It's like, we've got a lot of digits. And it seems to have pretty dang good agreement and everything. And that's the thing. Sometimes it's like, I've had folks, again, send me some things before, and it's like, okay, this determines alpha. You look at it, you go through, and it's like, I'm going through here, and it's like, okay, I hear what you're saying, but it's like, just 1 over 137 is more accurate than this. It's so that's the thing. It's like certain things, like example, like speed of light. For a good while, we knew it, or we were claiming it to 0 significant digits. That's an unfair thing to say. The reason why I say that is because it goes like 2.9978 times like 10 to the 8 meters per second. That looks a lot like 3. A lot of people will still do 3. And depending on which LLM you're going to put in, it literally will just do 3 times 10 to the 8. Now, if you're just going to say approximately and just do a quick back of the envelope calculation, that's fine. But it's like if we have the speed of light either measured or right now it's defined at 9 significant digits, if you're going to deviate, you're going to need a pretty good reason there. And that's one of the things, because I can see, like, was it on Blue Sky earlier? I was Professor John Bays was posting something about like the weak force and everything, and he gave a link to a Wikipedia article. He's like, I should probably explain this better sometime. So I look at it. It says something about like heavy light mesons or whatever those may or may not be. I'm just looking. It's like, all right, it's now been constrained to about 348 mega electron volts. So I look at that and I'm like, okay, this seems to have something like this. I'm like, oh, does this have anything to do? Okay, I'm realizing I had a very ill-posed question for him because I just added in dimensions. Oh God, that was a terribly naive question. I just realized the error I made because I slapped on divide by meters cubed. Long story short is that comes out to be about. We'll just show you rather than just ramble on. Here's a whole bunch of numbers you don't understand. Let me go through it step by step. All right, tab from alpha. Okay. So what was it? Actually, hold on. I think I have chiral symmetry breaking. Here's what he was talking about. Bring this up here. Swap to this tab. Okay. So long story short is heavy light mesons. Okay, so they narrowed apparently the mass gap around that 348 mega electron volts. Okay. The problem that I realized the error I had here, 348 MeV. Oh, let's share this tab. Okay. And I noticed, okay, well, if you went down about 1 order of magnitude, that's about the vacuum energy density. So, and you see it's about 2 times the QCD scale. So I'm like, all right, well, in kilograms, it's this. I just divided by, here's the problem. I just literally inserted divide by meters cubed here. And I asked, does this have something to do? Is that we live in like long story short, it's about 1/4 the quote unquote dark energy. So I'm like, does this have a consequence of us living in 4 or 3 + 1 dimensions or something? I realize the error I made right now. Okay. Yeah, see, this is why it's good to like actually say things too, because I'm like, oh, here's a clever idea. It's like I just looked at that real quick and I didn't even know, and I realized in what volume are we talking about? Because to be fair, if you did that in the Planck scale, hold on, so we did Planck's constant. Oh, let's just do h bar. H bar divide by c squared times c. Actually, no, just divide it by speed of light. Just divide by speed of light. That should work. Okay. To be fair, would be more in a volume of something like this, or maybe like 2 pi. So like 2 pi. So I'll do the same spherical cow thingy. So okay, this energy density. 348 MeV. All right, divide by that cubed. Okay, that's a lot. That's a lot more than the dark energy. Yeah, that's 40. Hold on, sorry. There we go. Yeah. This is what we get when we do the Compton wavelength. Yeah. Okay, never mind. Yeah. That's over 42 orders of magnitude over the vacuum energy density. Wow, I was so wrong. See, look, big science made me wrong. Why? I got confused. Therefore, it's all their fault. Why? Because some podcasts said it was all their fault. I'm sorry. I'm being a dick. Well, it is my middle name. Let's see. To be fair, we do actually know dark matter exists, because at least Bill was pointing out that black holes do kind of seem to be just a mass or invisible matter. And then we also have neutrinos. Neutrinos fit the definition of weakly acting massive particles. Now, we believe there aren't enough neutrinos. And then neutrinos in and of themselves, very often they appear to be going at the speed of light, even though they have a mass. Seems kind of weird. Now, it's really itty bitty mass, like a million times or so less than an electron. What is it? Electron's 10 to the minus. Yeah, about a million or so, maybe 10 million. Give or take, depending on the flavor and the period of oscillation or whatever the heck a neutrino is. Yes, but neutrinos, if it's going at the speed of light, long story short, is if it's going at or around the speed of light, we consider that hot, dark matter. Cold, dark matter means that it's not going there. It's just kind of there. So in order for there to be neutrinos that are just kind of chilling, like, we would need a lot of neutrinos. Now, I know Echelon, when he was working on his physics library, and the whole concept of Echelon's physics library was that he's kind of an OG programmer, and he's like, I'm always had the title of a computer scientist. It's like, I don't feel like I've actually been doing computer science. I've just been kind of, all right, plop this in here, plop this name, address, zip, blah, 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 blah. So he kind of got bored and he started working on his own actual, like, library of things. And the interesting thing is, he's like, well, what's the most efficient process? It's like, all right, if you're going to attempt to make the most efficient computer resource library available, what would you base it on? Well, the simple assumption that, well, reality is probably the best process of doing stuff and things. Long story short is, as he got his library closer to the laws of physics as we know it, his quote unquote superpowers seem to explode. Like, his ability to run things with less intensity. Like, he was showing me scripts from a standard library and then his library, and it's okay, this goes from like 4, 5, 6 lines of code down to like 1.5 or so. It's like, that seems to be an efficiency increase. Maybe that's telling us something. So again, who knows? Hey, who knows? Maybe we're just living in some hologram or something. Maybe it's just a simulation. Now, we must remember, with God, all things are possible. Now, some folks may tend to agree with that because they have a particular thought of what's going on. Now, if we were to say, okay, we cannot roll out the Almighty, but just in case, can we attempt to model this in a way that makes sense? Now, some folks may say, oh, the God is a silly hypothesis. It's obviously a scientist in a lab coat. It's just an alien scientist in a white lab coat is how we got here. So what you're saying is, somebody wearing what some may view as a white robe created everything. It kind of seems like the same thing. Okay, so deity aside, can we try to explain what's going on? And now maybe we can't. Maybe we can't. Maybe it's those initial conditions, maybe those are just beyond our reach. Now folks will say, oh, we can go back to like half a second after or a second after the Big Bang or whatever we consider may or may not have happened. Again, it's some folks may disagree with that. I know certain friends like Anastasia and Shiloh may or may not have some issues with this, and that's totally fine. My personal opinion, I kind of think they kind of came from a hot, dense state. Now, again, one of the big things was modeling. We took away from Kurt's earlier post, and one of the things that Rick at the Frontiers of Science had been asking Dr. Freeze is, well, we have this observational data, okay, and then we put it into the okay. Oh, I think I actually have a photo. Okay, so that's what prompted my. Hold on, I need to find where this was, because this was over. This is from the. Okay, this was actually from an experimentalist that was at the ICTS. Where was that? Okay, he had a very interesting thing. Where was it? Oh, God. Far too many things. Okay. Oh, God, all the extra things that you just kind of look at. You're like, there. Okay, recently, I'm looking. Where was this? It was something that just stuck out to me. This guy. The Fourier transform. Okay. I think it's. Okay. I think it was something about the modeling. Where was it? Basically, it was on basically quote unquote missing energy within particle collider physics. It's like sometimes it's like, well, we have certain things, we're assuming this, we're assuming that. Did we assume it built in with a wiffle ball bat? Cannot say. Where was this? Oh God. Okay. Okay. It was towards the beginning, I think. All right. Where is that? Okay, something emergent phenomena. Temperature calculated numerically. Okay, I think it was somewhere around here. I think it was so just first a little don't mind okay, hard process lecture recap. Okay. So okay, here we go. I got it. So number one of the things that was interesting was sometimes you'll get emergent phenomenon. Now, if we consider, where is this? When you pack particles tightly together, new things happen, aka emergent phenomena. So we can see the phase diagram of water here, which is interesting. Unfortunately, these diagrams are not the same. You actually need to flip this the other way because you see heat is on the bottom axis here, heat is on there. As you can see, there's a kind of an interesting shape there. The water has vapor under those pressures and temperatures. It's a solid in this state. That appears to be well, that is the triple point of water over there. This is a point between a liquid and a solid. Critical point over there. And then you got quark gluon plasmas over there. And again, we'd have to swap those axes. But let's close this window and look at this, I think, is what I was looking for. This will end on a philosophical note. I thought it was kind of cool that experimentalists were sharing this. So, all right. Science. More is different. Broken symmetry in the nature of hierarchical structure in science. Okay. The reductionist hypothesis may still be a topic for controversy among philosophers, but among the great majority of active scientists, I think it is accepted without question. The workings of our minds and bodies and all of the animate or inanimate matter which we have any detailed knowledge are assumed to be controlled by the same set of fundamental laws, which, except under certain extreme conditions, we feel we know pretty well. It seems inevitable to go on uncritically to what happens at first sight to be an obvious corollary reductionism, that if everything obeys the same fundamental laws, then only scientists who are studying anything really fundamental are those who are working on those laws. In practice, that amounts to some astrophysicists, some elementary particle physicists, some logicians, and other mathematicians, and a few others. Okay. So, and again, slightly different context, but it seems to kind of go into the whole, we see a thing. What are our assumptions? Well, we got a model. What does the model say about this? These stars are going far too fast. There's obviously dark matter. Where's the dark matter? It's in like a spherical halo around the thing. Now, I'm sure that has nothing to do with modeling a disk galaxy as a sphere and all of a sudden being like, we're missing matter. We're missing matter. What might be going on? So, I mean, if somebody could explain why that is the case without adding all these epicycles and everything like Mon, and then having to have this extra tensor field like Dr. Freeze was saying, and then all these other things that we need to account for. Oh. Let's see. All right. Yes. Welcome, Tommy. Yes. Well, Boltzmann's constant is basically just that conversion between temperature and energy. Yep. All right. Welcome, everybody. That's okay. It's okay. Hey, autocorrect for the win and lose and everything there. Now we're just talking about how big science is totally, it's totally hiding the truth. Now, again, I don't know who big science is or what the truth might be. But remember, if you heard it on a podcast you like, it must be true. That said, take care, everybody. We jumped around a little bit there. We should be doing some stuff and things. I think Piper Fizz's roommate is doing bringing the quote-unquote effort show back tonight in about an hour or so. So feel free to visit over there if you would like. But that said, peace out, everybody. Take care. It's a wacky, wild world out there, but it's open for a better tomorrow. Peace out, everybody.